Hello, welcome to our today's webinar. Our topic today will be the calibration and the maintenance of our IRS31 road sensors. It's a part of the segment traffic here. And I will show you different things today. First of all, of course, I will show you how to use the calibration kit for the IRS31. That means we will check together today, also interactive, how to do the water film calibration procedure and how to do the salt concentration measurement procedure or freezing point calibration procedure together. That's the first thing. And the second thing is how to get out the electronic part of the housing. That means how to do that, what you need, materials and all this stuff. So this will be the second part today. But we will start with the IRS31 calibration kit so that you can be able to do your calibration on site. Of course, you will be able to ask questions if you want. We have again the small question box here on the right side of the menu where you can of course put in your own questions regarding today's webinar. And we will try to answer all the questions you will have in the future or today or yes. So please use this function. It is of course a very good function for us to get feedback of the webinar. So the first thing is, because doing this calibration on site is not so easy because you have to know the function of the IRS31 itself. So the first step today, or the first thing is, I want to show you again the different measurements which are really important for this calibration. So normally there are three measurements which are the important calibration measurements here. The first one, you see that on the page, on the sheet here, is the water film. And the water film, I will show you that here with the camera. You need to know that we will have a radar sensor inside the IRS31. This radar sensor here, it's placed here. You will see the dark shadow here, and there the radar sensor itself is placed. And this radar sensor is used to measure the water film up to 4 millimeters in the case of the IRS31 here. What you need to know in addition is that, of course, normally then you can think you can put the water here and that's it, and then the sensor will measure. No, it will not measure, because we have an additional measurement here with the two steel electrodes here. This is an internal measurement. It will not be shown as an output, but it is used to regulate or to activate this radar sensor. Why? It's easy. Think about, maybe you will have a leaf or an insect running here on the surface. That means if there is something which is not water lying on the surface, this will be a reason to show a water film. And of course this is not a thing the customers want to have. So in this case, the radar sensor will be activated only if here between the two electrodes we will have some liquid, some water. Because it's a capacity measurement here, and if it's dry it has a special capacity value, and if it's wet or damp it will change the capacity. So that means if the capacity will change to damp or wet here, the radar sensor will start to measure. So that's really important to know if you want to do the calibration on site later. So that's the first measurement here, which I want to explain to you. So you see that here again, it's the first part, water film measurement up to 4 millimeters by microwave radar sensor. Resolution is 10 micrometers. It's a real accurate sensor here with an accuracy of 0.1 millimeter plus 20%. The second important measurement for the calibration on site is the freezing point detection, right? And of course also the salt concentration measurement. And this will be done also on top of the sensor, and I will show you that again here, and it's made here. We have these two electrodes which are used to measure the conductivity here. And the conductivity will change depending on the salt content in the liquid which is on the surface. So that's again the same thing. If the conductivity value says it's only water, then of course the freezing temperature is 0. If the conductivity value will change, then the sensor will output you, depending on the conductivity value, the freezing point and the salt concentration. So that's really important. What you need to know again also, this conductivity measurement is really depending on the water film and on the temperature. That means that, for example, in the German regulation, which is called TLS, it is said that under 50 micrometers, 50 micrometers, you cannot detect the freezing point. That means also, because our radar sensor is really sensible, for example, you will have a water film of 30 micrometers, you will get no freezing point in this case, because the sensor will start with 50 micrometers to give you the information about the freezing point. That's one thing. So it's depending on the water film and it's depending on the temperature. That means this sensor is adjusted at 0 degrees for the freezing point. That means you need to have minimum, or the best, the optimal freezing or outside temperature is 0 degree to get the best performance here. So that means if you want to do the calibration outside in the summertime, for example at 25 degrees, this measurement will not be very accurate, right? So you have to know that. So the best day for such calibration will be a day with 0 up to 5 degrees Celsius outside temperature. And one also important thing here for this measurement is that it is a passive measurement. That means this sensor, this IRS31, is adjusted to natrium chloride. So you need to use natrium chloride, sodium chloride solutions to check the sensor itself. So that's the second one, and these two measurements, the water film and the freezing point, will be part of the IRS31 calibration kit. Then we have the next important, the last important measurement, which is the surface temperature measurement here. This is done here, show you again, under this electrode. Under this electrode we have an NTC. This is a resistor which changes its value depending on the outside temperature or depending on the temperature itself. And so that means here we have the temperature measurement, and of course in addition to check the freezing point and the water film, you can also check the surface temperature. For this you need an external, a special measurement, a special device. That means, for example, a handheld with a surface temperature probe. For example, you can get that also from Lufft, or you can also use any other type of reference device here to check the temperature on this point, which is the surface temperature. Okay? Right, so these are the 3 important measurements for the calibration. So let's go on. So now I will show you the IRS31 UMB calibration kit, which you can get from Lufft. And you will see it on the picture. We have different parts here for the calibration kit itself. So I will show you these parts live. We have a plastic ring, including 2 screws. You see that on the picture. Of course, the IRS is not part of the calibration kit, right? So this is the ring here, the plastic ring with the 2 screws. With the screws you will be able to connect the ring with the IRS, and then you have the plastic ring itself with a sealing here, which will seal the housing against water drop. So that's the first part. Then we have this 2 sodium chloride solution, natrium chloride, for freezing temperatures -2 degrees. That means 3.5% of sodium chloride. and minus 10 degrees Celsius, which is 13.1% of sodium chloride. Again, I will show you that also live here. So we have one bottle and the second bottle. 3.5% natrium chloride and 13.1% of natrium chloride, which is part of the calibration kit. So then we have, in addition, we have this stamp here, this plastic stamp. This stamp is used for the check of the freezing temperature. I told you that we have the problem here that the freezing temperature measurement is depending on the water film. And to create a stable water film, we have this stamp here, this insert, which will create a water film of 1 millimeter. So we have to put that on the surface later. I will show you that anyway, how to do it. And of course you will have also 2 syringes, something like that, to fill in the water. So this is these are the parts which are available if you order the IRS31 calibration kit here. So again, you see that on the left side you have the plastic ring with including 2 screws, you have the sodium chloride solutions, natrium chloride, you have the plastic insert with a height of 1 millimeter, and you have the 2 syringes. So now we will start with the first calibration. The first calibration I want to show you is the water film calibration. And I will show you how to do that now live on the screen, right? So, first step, you have to install the plastic ring. I will show you that now. So you always have to remember that this will be done on the road, right? So we will do that here on the table now. It's a little bit easier here, of course, but it's the same procedure. So you have to unscrew first 2 screws. This one, the middle screw on the left side and on the right side. So we will do that now together. Unscrew it. One. And 2. Now you can put the plastic ring on the surface on top, and you can fix it with the 2 screws now. It's a special key here. It's a hex wrench, free, size is free. Hex wrench, size free here. So fix it now. Don't fix it too strong so that maybe the plastic ring will break. So it's only needed to fix it. You will see it, the sealing will attach to the surface, and that's okay. So that's enough. So now the water cannot escape anymore from the sensor itself. So that's the first step. Now, of course, what is needed to check the calibration or the values is the UMB config tool. So normally now you have to open your laptop, you have to start the UMB config tool, you have to connect the UMB config tool, the laptop, to the station. We will do that now. So that means you have to go to Edit, Sensors, you have to put the IRS into the selected sensor list, you have to activate the channels which you want to see. Normally in this case, of course, because we want to check the water film, you have to activate a water film channel here. After that, you go to Save and Exit. We do that very fast. I don't want to explain you now the UMB config tool. That's an extra webinar, an extra video which you can check on our homepage, how to use the UMB config tool. Then you have to start the measurement. And now you see I have here on the left side, I have the road temperature, I have the water film height, and I have the road condition, which is normally not needed. So the needed value is the water film height itself. But I have, anyway, it's always interesting to know the road temperature. So now I switch back to the camera here. So now we start to fill in some water. And now you can, of course, ask, okay, how much water? And that's explained again here. If you see that here on the bottom, you see water film height 1000 micrometers. This is the water film height we want to check, 1000 micrometers. So, and if you want to check this 1000 micrometers, it's depending on the area of the surface. So that means the area here, we need to create 1000 micrometers to measure. And we have, of course, calculated the quantity of water which you have to put in. And you see that it's the water quantity to create 1000 micrometers for this area is 5.6 milliliters. So this is the sum or the quantity of water which you have to use. But now you can see there is the note here, important. And it's written, use 2 milliliter more water to fill in the gaps. That means 2 milliliters plus 5.6 milliliters is together 7.6 milliliters. Why? You have these small gaps. Here is one of the hole in the gap, and around the electronic part you have gaps. And first of all you have to, of course, fill the gaps with water. And this, to fill them, that it is really flat, is 2 milliliters. So you have to add them. So together it's 7.6 milliliters of water. So we will do that. So here's the water, here's the syringe, and I will fill in now 7.6 milliliters. And we will put that now on the surface. So now you have, of course, to check that the water is everywhere. Of course, it's easier for me here because it's on the desk. Normally you can use the screwdriver to put the water everywhere. It must be placed on the complete surface, flat on the surface. So that's it. And now we switch back to the UMB config tool. And you see, now we have a changed value for the water film. So it's about 1142. Normally it should be 1000. Of course, I have done it now very fast. I have not really checked the 7.6. Maybe it was a little bit too much. But of course, if you are in front of the station, you can do that more accurate, as I have done it now. But you see, it's around this value. So you will get a value around 1000 micrometers. And normally, I will say if it's really 7.6 milliliters of water, yeah, and if it's really built in the right way, that's also very important, then you have a tolerance of plus minus 50 micrometers. That means if it's 1050 or 950, that's okay. And you see now it's going a little bit down because now it's really going flat on the surface, and it seems to be okay now, right? And that's the tolerance. But again, it is really important how the sensor is built in the street, because Lufft, we recommend that it has to be built in really flat, and it's only working if the sensor is really flat. Because again, I told you the radar sensor will measure here. And what will happen if this sensor is not really flat in the street? For example, I will show you that now, something like that. You see that the water will flow down. Well, and or on the other side, it's the same thing. And then the value will not be representative anymore. So normally, to check it, you need to have a flat built-in sensor on the street. That's really important. If not, if it's a little bit not flat in the street, of course you can do also the calibration here, but maybe you will get some wrong value, so you have to know it. All right? So that's the first measurement here, and now we have about 1075 micrometers, which is not bad. All right? I hope that is clear now. All right? So we will go to the next step. The next step is the calibration of the freezing temperature. So I switch back to the camera now. Of course, now we have the first thing we need to do is we have to empty the the plastic ring water inside the plastic ring. That's easy for me here. You see that? I can do it like this. Of course, if you are in front of the station on the road, normally you can use a cloth, something like that, and you have to dry the surface like this, and then you can check again if the water film is now 0. That's the first thing we need to do after we have checked it. We have to go back to 0 now. Okay, now you see it's back to 0, it's dry now. Now we can start with the freezing point calibration. So, all right, so that's the freezing point calibration, but what we will do now. I wanted to show you something else, or tell you something else about the measurement. I will do that later. So anyway, so we will start with the salt. Again, what you need to know is that's different to the water film calibration now. We need to switch off the radar. Why? The radar will influence the measurement because we want to have a stable water film. We will do that with this insert. If you put the insert on top of the surface like shown here on the picture and the radar is active, you will get completely distorted values because this insert will influence the radar measurement. So that means before we start to check the freezing temperature, you have to deactivate the radar sensor. Now, of course, you can ask me how you will do that. That's easy. You can do that with the UMB config tool, and I will show you how you can do it. Here is the theory. That's the theory. You have to open the UMB configuration menu for the IRS31, and you see it here. You have two things which you can change here. First of all, the measurement parameters for the measurement interval. You can go down to 10 seconds if you want, so you will get fast changing values. So that you don't have to wait so much. That's what you can do with the interval here. And the second thing is the deactivation of the radar. And this will be done here with the conductivity measurement test mode. That means start test mode through changing the value from 0, which is the standard value. 0 means radar sensor is active here, to, for example, 3600, which means seconds. 3600 is 1 hour. And if you put a value here inside, for example, 3600, the radar sensor will switch off for 1 hour, for example, in this case. All right? So I will do that live here again with you. So we close the measurement, stop the measurement. We go to Edit, Sensors. Here is the IRS, the road sensor. Go to Configure, Load Profile from Sensor, load the profile. Now you have the IRS31 UMB minus UMB menu, and you will have the measurement interval here for 10 seconds, and you will have the conductivity measurement test mode here, which is 0. Now we want to deactivate it, so put in 3600, which is 1 hour. Then go back to main and say, okay, store this profile on sensor. Now this profile will be programmed and the radar will be deactivated here. You have to wait a little bit. So after that, configuration is written to sensor. Now the radar is deactivated. We can activate the channels we want to see. For example, again, the road temperature. We do not want to see the water film. This is not important. We want to see the freezing point. So go back. It's 151, I think. Activate the freezing point and say, all right. So save and exit, and now you can start with the measurement. Right? And now we have to prepare the salt. So I will show you that again live. So it's showing here on the screen, and we will do that live now here. So we have the sodium chloride. For example, we will do that together with the 3.5%, which is minus 2 degrees Celsius of freezing point. And what you need to do now, you don't need to check the quantity of the sodium chloride, because we will do that with the insert, the stable water film. So you can fill the complete syringe with this sodium chloride, put it on the surface so that the complete surface is covered, and now you use the insert here and put it on the sensor. Check that there are no bubbles under the insert. So you have to check that there are no bubbles. Bubbles will influence the measurement, especially here where you have the two electrodes. There should be no bubbles there. And then you can start the measurement. And we go back to the UMB config tool, and hooray, you see that? That's great, because again, it's depending on the outside temperature. And you see we have 22 degrees here. Normally it should be a bad value, but the sensor here is a very good one with a very good measurement. So you will see the freezing temperature normally should be -2, right? The sodium chloride which we use is -2, and you see it's -2.7, which is not so bad. Normally it would be better if we have an outside temperature of maybe 5 degrees, or the best way should be 0 degrees. Okay? And now you have checked also the freezing point measurement. Now you can of course use the second fluid to check also the -10 degrees freezing point. No problem, but you will see it's okay here, right? So let's go back. Again, here the notes, right? You have to cover the surface completely with the sodium chloride. You have to use the plastic insert to create a fixed water film. Then you can start a measurement. The notes are very important. Here, please check again the notes. The measurement of the sodium chloride solution depends on the outside temperature. Therefore, the measurement is in the IRS31 has been adjusted up to +5 degrees Celsius. So you have to do this check under the outside conditions of 0 up to 5 degrees Celsius. And the second note, we need to switch off the radar measurement before starting the calibration. This will be done using the UMB config tool. We have done that together. So that's really important to know. You have to know that. So, all right. Now I want to show you the channels which you have to activate for the different measurements. For example, for the water film calibration, the important channel here in the channel list which you have to activate to check it is channel 601. That's the water film in micrometers. Maybe you are using the sensor where the inch unit is used, so you can also activate 602, which is the inch unit for the water film. Normally this is used in the USA. Then you have the calibration freezing temperature, and this channel is channel 151 in the UMB channel list for the IRS31, and that's the freezing temperature in Celsius degrees. If you are, again, you need the degrees Fahrenheit value, you can also activate 152, which is the Fahrenheit unit here. These are the channels. So that's all for the calibration. Normally now we have done it. Of course, remember, you can also in addition check the outside or the surface temperature, which is used using the a special external device, for example a handheld from Lufft or any other handheld or measurement device which is calibrated, and you can easily check the temperature using the probe. For example, if you maybe this is the probe here of the external device, you can put the probe here on the surface, and then you can compare the value of the road sensor with the value of the probe, and they must be inside the technical specification. That's all what you need to do. That's really easy, right? And then also the surface temperature is checked. Okay, so I think that's all for the calibration. Now we go to the next part, which I want to show you. The next part will be the removal of the electronic part of the IRS31. So, if you want to do that, what is needed? And that's an important thing here. That's a really important thing, because if you do not remember this, you will get problems maybe in the future if you change the electronic part. So needed equipment is the hex wrench, size 3. And that's a really important thing. Normally it's a special hex wrench which you can also configure the torque. Because the sealing which is used with the IRS31 needs a torque power of 2 Newton meters, so that the sealing is really working the right way. So normally you cannot close the electronic part and screw the screws only with the manually. You need to know the power, and that's 2 Newton meters. All right? Then the second thing what you need is the 8410.SSET. It's a sealing screw kit for the IRS31, which you can get from us, from Lufft. And I will show you this kit live here again on the camera, and then you will see what is included here. So this is the kit, and if you open the kit, you will see what is inside. So that's all the stuff what is inside. You have a dry package silica gel, which you can put inside the housing, which will detect humidity. Then you have, of course, the most important part is the sealing here, the plastic sealing. Then you have one package with 6 new screws to fix the electronic part, and you have this grease which you can use to put on the sealing, so that the sealing will be not so morbid, or more morbid, let's say it like this. So these are the parts which are inside the box, right? And what is really a must here, and that's a must, and we recommend that to do that always, is if you open an IRS31, you have to change this sealing. The plastic sealing must be changed. The reason is easy. The reason is that I told you that the electronic part will be fixed with a special power, with 2 Newton meters. And now think about, if the sensor is working for 1 year in the same housing and you open it, then of course the sealing is a little bit changed. The form is not the same anymore, because you have 1 year of 2 Newton meter powers working on the sealing. And maybe you do not see it, but the shape is changed. It's bigger. And if you use the same sealing again, I will guarantee that the water can go inside there, because it will not fit in the housing anymore. So it is a must to change this sealing. If you don't have it, you can order these sealings from Lufft, no problem. All right, so that's a must. So now we will do it live here, or I will show you how to do it. So you have the hex wrench here. You open the 6 screws. One, two, three, four, nearly done, 5, and 6. So now you can also in addition use a screwdriver here, this one for example, to pull it out. There is this small hole that is extra done to use a screwdriver if maybe the electronic part is not so easy to get out. So you can push it with the screwdriver here, and then if you open it, you will see there is the sealing here. See that? Lying here in this special shape here in the housing. Then you have the cable and you have the plug, and so you can unplug it now easily and change the electronic part. Normally you have one plug or maybe also two plugs depending on the version of the road sensor which you use. You cannot change them, you cannot mix them because they are specially coded. So normally if you have two plugs here inside, they cannot be mixed. So now you can change the electronic part. So let's do it. For example, changing this one. So you get out the old sealing, you put in the new sealing. And normally it's done like this. Put in the sealing here. There is a special part where you can put the sealing in. Then you use this fluid, put it on the sealing so it becomes more morbid for over the time. Then you have to connect again the road sensor to the connector. Then you put it inside slowly, and that's it. And now I will do that always like this. You try to move it a little bit, and then you will see that the sealing is really fixed and in the right position. And now you can fix it again with the screwdriver. And now you have to use this special wrench, this hex wrench with a torque of 2 Newton meters. So to use the right power for the sealing. I will do it without this special wrench because I do not have it here. But normally here, if you are in front of the station, you have to use it with 2 Newton meters. And after this procedure, the electronic part is changed. And I think it's an easy thing to do it. The most important thing is to use this new sealing. That's really important. If you do not do it, you will get problems with water which will go inside the housing here. Okay, so the last two. Of course, you can also get a dummy inlay. That means if you have to send back the sensor, the electronic part, you can put in a dummy house or a dummy part with no electronics so that the housing is closed, right? So that's it. Now it's closed again. And now you can, for example, start again the measurement or something like that with the station. All right, so I think that's it. Do you have some questions? If you have some questions, please write them into the box. We will wait a little bit, some minutes now, and then you can ask me some questions. Maybe something was not clear or something like that, so you can ask now. We will wait a little bit. In the meanwhile, thank you very much for your interest. I hope it was informative for you. We will have new webinars in the future. For example, we will have a new product. It's a new road sensor called IRS31 Pro. This will be available in the next 2 weeks. And of course, we will also do a webinar for this, right? And of course, we also want to do a webinar for the non-invasive road sensor, which is the NIS31. Now we have a question. Can we use the stamp for water film height calibration? No. This water film, this stamp, of course, is simulating a water film. But if you want to check the water film, you want to check the output of the measurement output of the radar. So if you activate the radar and you use the stamp, this will not work. The radar sensor must really be checked and calibrate it with existing water. So that means radar sensor active, you put water on it with a special water, with a quantity, which is the 5.6 milliliters for this area, and then you will get this 1000 micrometers. That's the procedure. You cannot use the stamp. The stamp is only to, let's say, simulate a water film without a radar. That's the thing. You know, you switch off the radar and now you need a fixed water film, and that's the stamp or the insert. Okay? All right, so thank you very much. It was a pleasure for me. Hopefully we will meet and see again. Bye.